We're going to talk about inequalities. Inequalities are what look like equations where you have something on the left side, and you have something on the right side, but instead of having an equals mark in the middle, you'll have a different type of symbol. And right here I have all the different symbols you could have. You could have a greater than symbol, a less than symbol, a greater than or equal to symbol, which is what this symbol means, a less than or equal to symbol, or a not equal to symbol. All of these symbols are called inequalities because in means not and equality means equal. So inequalities means not equal. So first we need to be able to read all these symbols, and remember that you read from left to right. This is our left side, this is our right side. So when I read the word read, I start with R and then E and then A and then D. So that's what I mean by reading from left to right versus reading from right to left where I would read D-A-E-R. We don't do that. Well, it's the same thing with working with math symbols. We read from left to right. So this first symbol that's used in 10 with the 10 and the 4 is the greater than symbol. The way I think about it is the wide open end is the big end and the little pointy end is the little end. So the wide open end always is going to be facing the big number and the little end will be facing the small number. So you can see in these two examples that the wide open end is facing the big number and the small closed end is facing the small number. So then we read the symbol from left to right. So if what I get to first is the wide open end, that's my greater than symbol. And I read this 10 is greater than 4. If I'm reading from left to right and I get to the small end first, then it's read less than. So this is read 4 is less than 10. So let's look at the symbols at the top and make sure you understand all of them. So again, this symbol is greater than, this symbol is less than. Now, if we have a line underneath our symbol, that means we're including equals to with that symbol. So this symbol is greater than, but it also includes equal to. So that's greater than or equal to. The next symbol, what do you think that is? Less than or equal to, right? And of course, this last symbol means not equal to, the equals with the slash through it. Try reading each of these. How would you read the first one? 5 is not equal to 6. Good. Try reading the second one. 8 is greater than or equal to 2. Try the next one. 6 is less than 11. Try the next one. X is greater than negative 5. So I'm going to ask you a couple of questions about x is greater than negative 5. If I let x equal 7, I get 7 is greater than negative 5. Is that a true statement? Sure, 7 is greater than negative 5. What about if I let x equal 4? Is this a true statement? Sure, 4 is greater than negative 5 because it's positive. What about if I let x equal 400? Is that a true statement? Sure, 400 is greater than negative 5. What about negative 4? Is negative 4 greater than negative 5? What do you think? Hopefully you said yes. Negative 4 is greater than negative 5. What about 100,000? Is this a true statement? Is 100,000 greater than negative 5? Yes. The point here is that all of these numbers make this a true statement. So there can be a lot of answers for x. X could be a lot of numbers. They could be whole numbers, they could be integers, they could be rational, even irrational. There are lots of numbers that could be greater than negative 5. So there's actually an infinite number of solutions to that inequality. And so the way we write that on a number line is we want to be able to express that x is bigger than negative 5. So it's going to be all the numbers bigger than negative 5. But we have to be able to express not to include the negative 5, but start as close to negative 5 as possible. So we're going to use what's called an open circle. Remember, the closed circle is the one that we colored in, and that meant to equal. An open circle means not equal to. So it means you start at negative 5, but you don't include negative 5. And this is how you would express x is greater than negative 5. So let's look at this in more detail. Keep in mind again that you are reading from left to right. So here are our inequalities. Anytime we have an inequality that does not include equals, like greater than, less than, or not equal to, we use an open circle to express that whatever number we have, we are not equal to it. So if I have x is less than 2, I'm going to use an open circle on 2 to express that we start at 2 but we don't include it. Anytime we have a symbol that does include equals, which would be greater than or equal to, less than or equal to, or of course equal to, we used a closed circle where we color the circle in, and that means equal to. So if I have x is greater than or equal to 6, I'm going to want a closed circle on 6 to say x could equal 6, but it could also be bigger than 6. Then we have to think about the arrows. So if you notice underneath each of these, I have some arrows. If we look at a number line, let's look at this first number line as an example. And we want to express that all of our answers are larger than a number, like an x is greater than 6. We would start at 6. I'm going to draw a 6 on this number line. And we would show that all the answers are bigger than 6 by drawing an arrow. So let's look at an example. Let's say I have the inequality x is greater than or equal to 1. Well, I know that with greater than or equal to, I do have an equals as part of my inequality. So we are going to use a closed circle. So I'm going to go to 1 and put a closed circle there. And what we're saying is that 1, which is equal to 1, will make this a true statement, right? So if I put 1 in the place of x, doesn't that give you a true statement? 1 is greater than or equal to 1. It is equal to, so it's a true statement. Now, any number bigger than 1 will also make this a true statement. So I'm going to draw an arrow going in the positive direction to show that all numbers bigger than 1 and 1 itself will make this a true statement. So there's two things that you want to ask yourself always. You want to ask yourself, should I use an open or closed circle, and which way does the arrow point? The arrow will point in the negative direction if it's a less than, and it'll point in the positive direction if it's a greater than. In this next example, we have x is greater than negative 5, which can also be written, by the way, as negative 5 is less than x. So just keep in mind that you can use notation either way. I like to have my x on the left-hand side, and I'll show you why in a few minutes. So in this case, we want to check our two things, the circle and the arrow. So what kind of circle would we have, open or closed? Is there an equals there? No, we would have this if there was an equals. So do we want open or closed? Which one represents not equal to? Open, right? So we're going to put an open circle on negative 5. And then are we looking at all the numbers bigger than 5 or smaller than negative 5 to be a solution? We want all the numbers that are greater than negative 5 to be a solution. So our arrow is going to point in the positive direction or the right side of our number line. Now let me explain in a little bit more detail why it is that we use it in an open circle. Keep in mind that we have an infinite number of numbers that will make this a true statement, right? So I could say negative 4.9 is greater than negative 5, and that's a true statement. So I have a solution right in here. Or I could say negative 4.99 is greater than negative 5. Or I could say that negative 4.999, you get the idea, is greater than negative 5. So I have an infinite number of numbers that will make this a true statement. And the only way that I can express that all those numbers all the way up to -5 but never including -5 are solutions is to use that open circle. It means start at -5 but do not include it, but start as close as you possibly can and then move in the positive direction, and all of those numbers will be solutions. Let's look at this next example. Do you think that's an open or closed circle? It should be closed, right? Because we have an equals mark as part of our symbol. And should the arrow go in the negative or positive direction? Should it go in the smaller number direction or bigger number direction? Smaller numbers, because x is less than or equal to 3. Let's look at the next example. X does not equal to, open or closed circle? Open circle, right? Because it's not equal to. So what we're saying here is that anything except 2 will make this a true statement. So what do you think we'll do with our arrow? It's kind of a tricky one. Anything bigger than 2 will make this a true statement, right? Anything, because it's not equal to 2. Anything smaller than 2 will also make this a true statement. So this is what your graph looks like for a not equal to symbol. Try these two problems. Graph each of these. These are the graphs for the next two problems. Make sure that you put ends on your arrows. That's really important. You want to have those little arrow symbols on the end. That shows that this goes on for infinity, forever. Go ahead and try these next two problems. Here are the solutions to the next two problems. Try graphing these two problems. Here are the solutions, or the graphing of these two inequalities.